To process the images for the first scan on this side, first had to pick the ideal HSV values. So I selected a picture here and found the HSV values which best isolate the laser from the outside noise. And then, as you can see, I've input these values into the data generation scripts. So after the data has been plotted, you can kind of make out the general structure of the railing. However, there's a lot of noise which we'll have to get rid of, which will be done in MATLAB, and you'll be able to see the structure more clearly once that has happened. So to begin the point cloud formation for this side of the structure, I first started by finding a new set of HSV values which helped to isolate the laser from the outside noise. As you can see here from this picture, I've found HSV values which isolate the laser pretty well, and I've entered these values in the data generation script here. So that done, I can run the data generation script, and it'll begin to loop through the images. So after the data is finished plotting, you can see what the plot looks like. It's very similar to what you might expect, as it's just a rectangle which basically is oriented vertically. And this same process was followed for the opposite side of the structure, which again looks very similar to this side. So here's the MATLAB file that I used to process the text file data and create the plots in MATLAB. The first thing that I had to do was remove the noise from the data, which you saw there's a lot of noise for that one particular side which I scanned. So basically what I did is there's a lot of noise in front of and behind that cross section of the railing that I scanned. So I just set a position restraint on, and just looking at the area where the majority of the points actually were, and cutting off the points that weren't real points being recorded. And then after that, I had to do some translating and rotating of the data. So here I translated data from one side. Here I removed the noise from the other side of the structure, and I had to flip that data 180 degrees so that it lined up with the other side of the railing. And then additionally, I had to translate that as well. And then for the data 2 and data 4, those were the two skinny rectangular portions of the structure. So I had to rotate those 90 degrees, and then also translate those, which I did while I plotted them. So when I run this, that's what it looks like all assembled. But just to show you an example of how I got rid of the noise, that was the original plot of one of the sides, and then when I removed the noise, it cleaned up a lot better, and you can actually make out some of the features of the railing. So here's the final plot of the point cloud from all four sides. As you can see, you can make out that circular wheel in the middle, as well as the railings on the sides. Each side was given a different color. So you can see on the side, like the yellow railing on the left side, and then there's the green on the right. And then the two larger sections are the blue and the red sections, which you can see are separated at the top right there. The one thing that you will notice is that there is some alignment issues. So some of the lines that should be on the same in the same X direction are kind of shifted, and I think this is due to the fact that when I try to change the angle of the laser, I end up inadvertently twisting the tripod left and right. So in the future I'll have to find a way to combat this issue and to keep the tripod straight the whole time. Additionally, I'll have to scan the structure from the sides at an angle instead of just one on each side, because basically there's just two-dimensional shapes, and then there's nothing really connecting them in between the railings, and so I need to scan it from certain angles where I can see the sides of the railings instead of just the front face. So in the future I'll have to do that as well.